in this length B, it has to be, if it hits right there and right in the center side, right there, then it'll create a 90-degree triangle, a right triangle. If it's smaller, then it won't hit at all, and the law of sines will not work at all. So you know if it's not going to work because the law of sines won't work. If it hits it once, you get a 90-degree. If it doesn't, it's less than 90, which is like 57 degrees, then you know it's going to create two triangles. Many different ways to look at this problem. Let's look at number 10. C equals 120, little a is equal to 10, and little b is equal to 12. Use the law of cosines, it says. Well, you don't really need to, you don't really even know if you have to use the law of cosines, but let's see. Let's call the C right there 120. That's A right there, that's 10, and then B is going to be 12. Big B, sorry. So big B right there is 12. Little a is right there, and I'm going to draw this triangle nice and neat for you, okay? I don't see that, you can't see it very well. Okay, so I'm going to start using this marker a little bit more because it's a little bit more stronger. So this is 120, this is 12, and this is 10. Okay, so how are we going to figure out what it is, what everything is? If you have an SAS situation, you have to use the law of sines, the law of cosines. You cannot use the law of sines because sine of the angle over that, we don't know what it is. Sine of this angle over this, we don't know what angle B is. So you have to use the law of cosines. We know that the law of cosines, c squared is equal to a squared plus b squared, just like the Pythagorean theorem, minus 2ab times the cosine of that angle c right over here. Did you get that, guys? C squared equals a squared plus b squared, just like the Pythagorean theorem, except it's minus 2 times that, and the cosine of that angle. Notice that law of cosines, so you have to use cosine right there. So c squared, c is equal to the square root of a squared, 12 squared, plus 10 squared, minus 2 times 10 times 12, times the cosine of 120 degrees. I'm not going to do the calculation for you, but you can do it on your own, get your answer. And once you figure out what little c is, from there, then you can use the law of sines to figure out the rest of the parts. About 2/3 of the way done, etc. Okay. Again, once you found this, now you can go sine of b over little b equals sine of c over little c, and you figure out what angle b is. From there, you can use it for subtract it from 180. Right? So that's mostly done. Let's do another problem. I think this works a lot better than the other pen. Number 12. A is equal to 10 kilometers, B is equal to 12 kilometers, C is equal to 11 kilometers, and it says use the law of cosines to the nearest tenth of a degree. I really don't care if I have to use the law of sines or cosines. I'm just going to draw it out first, and I'm going to try to draw it out to scale. That's the biggest one, that's 12. The next biggest one is 11. That's equal to B, that's equal to C, this must equal A. And since that's little a, big A is over here, little c, big C is here, little b, big B is over here, opposite. Of course, since I don't have any of the sides, I just can't do anything. That is, use the law of sines. Can't use any of these angles because you're going to be trying to solve for both at the same time. It's almost impossible. Well, not almost impossible, it's doable, but extremely difficult in your situation. So, what I'm going to do, you're going to use the law of cosine. So if you have an SSS situation, you're going to use the law of cosine. So if you can pick anything we want, any formula, let's try a squared is equal to b squared plus c squared minus 2bc times the cosine of big A. Again, it's just kind of like a squared equals b squared plus c squared, kind of like the Pythagorean theorem, except this is the hypotenuse, minus 2 times b times c times cosine of that big angle. I'm going to do a little something here. I should have wrote it on the right side. I'm going to subtract b squared here, subtract c squared here, and then divide it by negative 2bc. And take the cosine inverse of the whole thing at the same time. So angle A, I'm just going to rewrite nice and neat. The cosine inverse, shouldn't have been there. It's a squared minus b squared minus c squared divided by 2b times c. I know the book does it a little bit differently. They factor out the negative, so it's actually b squared plus c squared minus a squared, and the negatives cancel. You can do the math if you want. I don't like to memorize this formula because it's too complicated. I already have one. This one right over here, a squared equals b squared plus c squared, etc. So this is the one I like to use. Okay, and we just plug it in to our calculator. Cosine inverse of a squared was 100 minus b squared, which is 121, minus c squared, which is 144, all over negative 2 times b, 12 times c, which is 11. Okay, let's see how that works out. 100 minus 121 minus 144, in turn divided by parentheses, negative 2 times 12 times 11. And we're going to take the cosine inverse of the answer. It comes out to be approximately 51 degrees. Okay, and since we found out what A was, now we can use the law of sines. Law of sines is a lot easier to use. So sine of A over little a is equal to the sine of big B over little b. I'm trying to figure out what this is, so I'm going to multiply by b. How do I solve for b? Take the sine inverse of the left side, cancels with that. b equals the sine inverse of b, little b, which is 12, times the sine of 57 degrees divided by little a, which is 10. And let's solve on my calculator real quickly. Sine inverse of 12 times sine of 57 in parentheses divided by 10. 12 sine of 57 divided by 10. I'm getting a domain error. Well, let's try this again. 12 sine of 57 enter divided by 10. It's coming out more than 1. Shouldn't be coming out more than 1. Sine of A over A equals sine of B over B. Sine of A, sine of the angle A is 51 over little a, which is 10. Is equal to sine of B, sine of the angle B divided by B, which is 12 right there. Multiplied by B right there. Oh, it's 51, not 57, excuse me. 12, user input error there. It's 12 times the sine of 51, there it is. And then, that should have been 51, not a 57. Can't read my own handwriting, not very good. Divide by 10, and then take the sine inverse of the answer. Comes out to be let's see, 68.8 degrees, or approximately 69 degrees. And then we can find out what little c is. Big C, the angle C, we take 180, subtract 51, subtract 69, and we should get 60 degrees. I'm going to do a real quick check on this. The biggest side was B right there. Out of these three, the biggest side was B. The small side was A, yes, right there, and so the smallest angle should be A, 51. Yep, it all worked out. And of course, this is the middle length. That should also be the middle length, which is C right there. 60 degrees is between 69 and 51 degrees. So it checked out really nice and neat. Make sure you understand how to do all of this, because the quick check is actually used quite a bit on the SAT 1s. SAT 2s, the subject test, this will come out quite a bit as well. The actual calculation is going to come out on the SAT subject test. This portion right here is only going to come out, the quick check is only going to come out on the SAT 1s. So make sure you know how to do a quick check. Number 14, find all missing parts of B 3.7. So this is 14. B is equal to 3.7, little c is equal to 6.2, and big A is equal to 35 degrees. Okay, so you have angle like this. That's A, 35. That's B right there. That's C right there, 6.2. Opposite that is big angle C. Opposite B, little b is big B. And so you have the SAS situation, and I'm just going to go part of it with you. So first you have to figure out what A is, little a. It's going to be the SAS situation, of course, and you have to use on the SAS the law of cosine. So A squared equals B squared plus C squared minus 2BC times the cosine of big A. You know what B is, C is, you plug it in. You know what the angle A is, and once you figure this out on your calculator, you take the square root of that, that's little a. You can figure out the rest of the information by using the law of sines. Okay, so most of it's pretty simple. It's not that difficult to work on. The ambiguous case is the one that's going to be a little bit more difficult. Let's go on to number 18. The diagonals of a parallelogram. So they're actually going to give you a parallelogram. I'm pretty sure, what's his name? I'm not going to mention any names. They like to give this problem on the test. I don't know why. You know, it just doesn't make sense to me very much. But they want to make sure you can use it in a application setting. The diagonals of a parallelogram is diagonal 1 is equal to 26.8. The diagonal 2 is equal to 39.4, whatever the units are, meters and meters. If they meet at an angle of 134.5 degrees, find the length of the shorter side. So the side shorter is equal to what? That's what we're looking for. So we're probably looking for this side right there. So here's the diagonal right there. We know that 26.8 divided by 2 is going to be approximately 13.4, because we know that diagonals bisect each other, cuts it in half. These are 13.4, this is 13.4. We should have actually used a shorter one, but it doesn't really matter. Actually, it does matter. 13.4, and we know this one, 39.4 divided by 2, is going to come out to be 14.7. So I'm going to draw this out for you, just this portion right here. So I'm going to use my marker right here and expand just this situation right here. That's going to be 13.4, that's 14.7. How do you know what this angle is? It says that the bigger angle, where it intersects 134.5 degrees. So that angle right there is 134.5. So 180 minus